So, let's begin. Why do we need GitOps approach? Because we are lazy. We don't want to do any mistakes, and we want to automate our processes as much as possible. So, let's take the simplest sham. We have one repository with code. Where is this laser? Or? Oh, thank you. Red button, okay. Our code with our developers, we can just put our Helm there and use the simplest system to deploy our code containers, configurations to our Kubernetes clusters. Easy sham. Oops, wrong way. Bit more complicated sham. We have multiple repositories, multiple size, multiple environments, and we begin to have problems. If we change something in one repository, in one Helm chart, probably we have any dependency in another repository, and we have to change, for example, service name, any endpoint, or any ACLs, whatever, at another repository. So we have to keep our code. Usually I forgot this word, sorry. Consistent. We have to keep it consistent and we have to automate it. So, if we have multiple environments and multiple repositories, our chaos is beginning. We have to keep in mind a lot of small things and we have to take care about everything manually. It is a problem. Especially when we have to propagate our change through our environments, it is just chaos. So, one possible solution. We can separate our development code, our microservices, or whatever, use a simple site just to build Docker and upload it to our storage, for example, ECR. And use a single source of truth. We can create a central Helm repository, and if it is one single source of truth, we don't have to keep in mind all specifications in all repositories, all versions. We have one source, and we have single code space. If we change something in one place, it will be automatically changed at another place. So, and it is way easier to deploy to multiple environments. After we build anything, for example, new version of any container, we just upload it and patching specific values file in our central repository, in our central source of truth. And then CI there works, it is second CI, and it is deployed to any specific environments. It depends on our branch where we made the change here. No, I mean in central repository. It is complicated to maintain it. For example, right now I'm doing project for GoDaddy, and they have the similar sham. It is just hell, but they have too much bureaucracy to improve it. Next, maybe we can automate it. So this is my regular approach, how I'm doing it. We have our code in the repositories. Developers own it. They doing something there. They build. They write the code. Then CI is building it, and we pushing our change to our dev branch in our central Argo repository. Instead of Helm, I prefer to use a JSONet. It is a special language for data templating. It is about 10 times faster than writing Helm charts. It is a way more powerful solution. And the secrets repo, I prefer sealed secrets. We can keep unencrypted plain secrets in special private Git repositories. Oh, it is available. It is not compatible with any compliance like a PCI DSS or ISA. But if you have a small company, it is not a big deal. No, come on, I know it is safe. If we keep it in private repository, we can control our access through Git authorization and authentication. It is safe, but impossible to prove it. Our central repository, it is internal, almost public repository, and already encrypted secrets going to our central repository. Any change will automatically deploy it in dev environment through Argo. It is a pool model. We don't have to keep in mind our CI systems. Maybe any CI works fine. Maybe it is failed. Maybe it is not. We don't care about it. We have a state from Argo. We have metrics. We have alerts. If something goes wrong, we can see it. And we don't have to take care of the sequence of our CI processes. For example, if somebody pushed code at the same time with other, we don't know which change will be deployed firstly. Here it is absolutely no problem. It is constantly check repository and pulling new changes and deploying it to our dev cluster. If we need to promote our change, for example, we get the stable state, Friday evening, we have to promote it to production, definitely. We just doing pull request. Here, this red arrows, it is our promotion, pull request, and here we can have a special person, like a security officer, who can check all changes that are going through our environment. Then our pre-production environment, QA team is working there, and then production. So, going next. I want to show you a few more advantages of this approach. Usually, it is only few. Got it. Sorry about that. I don't know how to do it. It is my first presentation live. Is anybody knows how to take it higher?
Then we want people.
No?
Maybe not. No? Yeah, no. Control plus not working. Control bigger.
Change screen resolution.
Yeah.
Super plus might be.
Oop, no.
You got me.
Control Shift 0 is what
Control
Google
Shift.
says for PyCharm.
For bigger?
No. Control Shift 0.
I tried scrolling
Control
too.
Shift 0 might be bringing you back to normal.
Yeah.
Control Shift Plus maybe?
No. Well, come on. We can see something.
Let's not make guesses.
Control mouse wheel maybe?
I don't have mouse wheel.
Oh, you tried to play each up?
No, it doesn't work.
I found my
Okay. I can comment. I'm sorry about it, guys.
Don't worry about it, it's before, it's okay.
So, usually it is one or two DevOps in small and medium companies. It is not a lot of free time. So I want to do the interaction with developers as simple as possible. It means, don't call me, Peter, please deploy some new version. No. You can just go to central repository, to the simplest YAML file, and for example, provide specific here new version if you want to deploy it, or some additional variables, parameters, whatever. Then all of this will be compiled and through JSONet, and we're creating Kubernetes resources for it. from this. It's a lot of JSON.NET code. No, it is like a Helm, but it is not Helm. It is better. Developer just come in here and can change something. For example, it is one of parameters that I'm passing to environment variable to check something in code. I don't know what are they doing there. It is just developer's side. Everybody have access here, and everybody can change absolutely everything. But each environment read only a specific version, specific part of this file. For example, it is a specification for dev environment, and we have specification for other environments. Everything going through Git, so everything all changes have a full audit. We can control who and when and why changed something. When we doing promotion between environments, in pull requests, we can see what exactly was changed. It is just version, or they want to change something in production. You can approve it or decline it. It is up to you. So, multiple environments, multiple specifications. For example, pre-prod. Versions, some additional settings for different applications. About secrets, how does it work? Secrets is going to secrets YAML. It is separated for few environments too, and this is encrypted secrets. You can photo if you want. Good luck. In cluster, we have a special operator, sealed secrets operator. It contains a special private key. When I changing something in secrets repository, it is call our operator in our cluster, encrypt this secret for that private key for specific environments, maybe for specific namespace. And then it is just patching this file and change some secrets here. ArgoCD sees this change and deploying it to our cluster. Of course, it takes the only specific version of secrets for specific environment. Then operator sees a resource encrypted secret, just decrypt it and put the plain secrets to our namespace. ArgoCD can't show you any secrets, and it is safe way to manage secrets. Let's go to Argo. Hold on. This is our dev Argo. There's a lot of different applications. Not where is everything? Got it. Filter. So a lot of different applications. It is a Helm charts. It is a JSON.NET deployments. Instead of use Helm, I'm using JSON.NET and doing the same deployments but easier. For example, let's check one of random application. Oh, too much. That's how it looks like. You can go to any application and see logs in real time, but here is no logs. Okay. Let's take another one. Oi. Oh, it works. If developers need to debug something and run it with other microservices, because it is a bit complicated to run it at local machine, they just starting it in cluster, go in there, check the logs, check the metrics, check the configuration. If they need to make some change, they just deploy new version, it is building automatically and deploying to dev environment. They can change any parameters for any application through our inventory file that I showed you before. And they don't have to ask me about anything. They don't waste the time to ask me and wait for my response or any other guys from the infrastructure team. No, if we have some. That's how it works. For example, how configuration looks like. Here we can see all our resource. It is useful for debug. Example about JSONnet. Let's take some random application. That's how code looks like. It is a very simple way to write the code. You don't have to take care about indents or any other complicated Helm things, because with Helm you're using Go templating, and you templating text instead of template JSON. It is a special language made by guys from Google and integrated to ArgoCD. A special language to work with JSON, to template JSON. It's very, very, very useful. Так. Yes, one more interesting thing. Here we have Argo workspaces. For example, in our inventory file, let's take this part. This is one of our applications. It is a ConnectFi, and ConnectFi could be deployed multiple times. For example, developers want to check any new idea, but they don't want to break our dev or production or whatever. They just creating here one more instance, just commit it, and in dev they have a special personal instance for tests, for everything. Or if you have any special clients and you want to deploy special versions, it is a way too. Sometimes your applications have to work with cloud services like SQS, SES, whatever. S3, for example. And when you dynamically deploy a new version, you have to dynamically create cloud resources for this instance. Of course, obviously separate resources. And this is why I'm using Terraform Cloud. We just, in the cluster, we have a Terraform operator. Here we just specify parameters for Terraform workspace. ArgoCD, we have new instance of ConnectFi, for example. It means we have to create a new workspace with new cloud resources for this instance. For example, this workspace creates some SQS, IRSA roles, and I don't remember what is S3 buckets. And then we put in a secret to our namespace where it was initiated. And then I mount this secret to our pods. This how I automatically passing new IRNs to our instances, to our pods. Why? Let me show you the result of it. Yes, the best thing about ArgoCD it is JSONnet. It is a very, very fast way to write kind of charts and manage all infrastructure through Kubernetes. We have a single code space. If we change something in one place, it will be automatically changed in all dependencies. We don't have to keep in mind anything. Single source of truth. We don't have any human mistakes. It is absolutely removed. We don't have it at all. While we propagating our change truth environments, we change everything. We check everything. We check our syntaxes. If I wrote a correct code, correct JSONnet, for example, we check our applications and we check compatibility while we migrating between environments. This is why at the last 3 years I have zero downtime for all services. ArgoCD have web interface. Yes, it is very, very useful for developers. They don't have to go to any special place to find the logs of exactly dynamically created instances. Of course, it is integrated with Datadog, but it is a long way to go there to select a huge filters. It is complicated way. Here they can find very, very, very easy way to show the logs in real time. And it is an iterative process of development when you're changing something, deploying, changing, deploying, changing, deploying, and you can have the result immediately without any complications. It is very useful. ArgoCD support multi-tenancy. It means you can split your control cluster. I don't know how to call it. And you can have multiple teams with different permissions. For example, one team have permissions to one applications, another team to another applications. It could be read-only, it could be write-only, access for some specific resources. It is very, very flexible. Yes, ArgoCD is incredibly flexible. That environment file that I showed you, it was built especially for requirements of this company. They want to deploy specific versions to specific environments, to specific clients. It was a business requirement, but I can implement absolutely any logic. For example, one guys wants to deploy multiple instances of Helm with different values and give different permissions for different teams. It is possible to. I can implement absolutely any logic with JSONnet. Disadvantage of ArgoCD, when you just have an onboarding of new client, of new company, it is complicated to move everything that they have to this new way. It is a lot of work. So if you work with startups or something like that without big legacy, it is an amazing way to use this approach. Yes?
I'm confused, so be patient with me. In your first paragraph, you says, this simplifies the speeds of writing templates 10 times and time is money. On your last paragraph, you say the disadvantage is the labor cost of initially writing templates in library. To me, you're saying different things, and I'm sure that's not what you intend. So you can help me understand.
Yes, sure. I already wrote a huge libraries. It is not a big problem. But if you're writing it from scratch, implementing this infrastructure from scratch, it is easy. It is just a few days to move everything. If you came to company and you have already big legacy infrastructure, and they have absolutely different strange requirements, you need to change it. You need to move it from the legacy code to JSONnet, and it means you have to rewrite a lot. That's what I'm trying to say. So, thank you so much. It's all.